Hello friends, let us start with this chapter, Exploration, Entering the World of Secondary Science. I'll read it and then I will explain it. In the middle stage, science invited you to be curious and observe world closely, to ask questions and find out how things work. So earlier standards, in 8th standard, 7th standard, you've learned to see the world, be curious, ask questions, why this happens. Now we are going to go deeper. We are going to ask how this happens. What is the mechanism behind it? So we connected ideas across the world of living and non-living, living things and non-living things. As you enter the secondary stage, this journey continues but with emphasis on deep exploration. Science is not only about what we know but also how we know it. Science is not only, it's how observation lead to measurements, how patterns are expressed using symbols and equations. So you observe a pattern, you try to write an equation for it, you try to explain the natural phenomena. That is what we are going to do, exploration. So sometimes we build some models, they represent reality in simple form, and then we try to model it, write equations about it, explain it. So exploration is the name of the textbook. We'll look more closely, think more carefully, and find out scientific ideas help us to make sense of nature, technology, and our place within it. So this is what we are going to do. We are going to see the world carefully. We are going to understand the scientific ideas and make sense of our living. Technology, whatever we have, science which is used in everyday life to make our life simple is technology. To reflect the approach of this textbook, page numbers have been thoughtfully designed and framed with magnifying glass and compass. Now this magnifying glass and compass represent something. You can see these boys. One boy is there, he is holding a magnifying glass, and this girl is holding a compass. So what does this represent? Here they have explained. So to reflect the approach, the magnifying glass symbolizes careful observation, noticing patterns and paying attention to what might otherwise be missed. So what you have to do? You have to observe carefully, notice the pattern. You have to pay attention to the details. Okay? Now, choosing appropriate model, asking right questions, and knowing the limits where to apply the idea. So first thing what you are going to do? Choose a model. Try to imitate the natural phenomena. Ask the right question. What is important? Prioritize. And then find out the limits of the model, the idea. Together, they'll tell us exploration in science is not wandering aimlessly. So science, we are not going to throw stones in dark. It's not going aimlessly. It is trying to make sense of a world with care and purpose. Okay? So this is what is important. Now let's go to the next page. Natural world is very complex. You cannot understand the things completely. So what do? You make it simple. And this process is called as modeling. So natural world is complex. Studying it in full detail is impossible. We cannot study it in full detail. To make sense of this complexity, science uses models. So what is a model? It is a simplified version of the reality. Okay, in physics, moving car can be represented one point. You know, car is very big. So what are you going to consider? The front part, the back part, the middle part? No, the whole car is one point. For simplicity, when we represent it on paper, when we do calculations, we consider it is at a point. This makes our life easy. Now in chemistry, we show it, the atoms and molecules like spheres, which is not the case. In biology, we show the cells as diagrams. They have 3D shape. They are different than what we are showing on paper. But this makes our life easy. So Earth may be treated as a smooth sphere, which is not so. There are valleys, there are mountains, but we make it simple. That is our Earth. Building such model makes assumptions. We deliberately ignore the details. That's not a mistake. We make our life easy. That's why we assume some things. For example, when studying the motion of falling object, air resistance can be neglected. So if an object, a heavy object is falling, okay, air resistance on it is there, but we ignore it. But when a paper is falling, then it will very slowly come down because of air resistance. So what details are you going to consider? You have to decide in the model. Now heart can be compared to a pump, but actually heart is made up of living cells. So you are going to forget about the living cells. You are going to consider it as a whole, as a pump. We are going to neglect the details. So remember that these choices are not mistake, but we are doing it is deliberately on purpose to keep things simple and still find the answers. Now here they have given the example of a cricket shot. So if you are playing cricket, you're holding the bat and the ball comes towards you and you hit it. So which details are you going to consider? The direction of the bat, the wind speed, the height of the grass, the brand of the cricket bat. You decide. Some details are not so important. For example, the amount of grass, air resistance, you can ignore it for simplicity. Air resistance, the spin of the ball and stitching on the thread seam have smaller effects, so you can ignore it. It has some effect, but it is very small. Ignore the details. Now let us model. Suppose you ride a bicycle to your home and you want to model the time it takes to go home. So what are you going to keep? What are you going to consider? And what are you going to discard? You decide. So as we explore science more deeply, we notice that it uses language very carefully and precise way. So if I say something, if I say mass, if I say force, I mean something. And it is very, very clear. It should be very clear. Because science uses such language which should be understood very clearly. So we have definitions of each of the physical terms, chemical terms. Now this allows scientists across the world. Now suppose I say mango. In Marathi it is called something else. Amba. In Hindi it is called aam. Okay. Now quantities such as mass, velocity, force and electric current are represented by symbols. Now they have given symbol small m. So you go in Russia, it is small m. You go in America, it is small m. Because in science, these symbols represent something which is understood globally, everywhere in the world, in the scientific world. M, which is small, is mass. Remember this. Now to make even more precise, science often turns to mathematics to allow relationships between quantities to be expressed clearly and tested carefully. Now mathematicians are the ones which help us to understand the relationship between different factors affecting a particular event. It can be a chemical reaction, it can be a physical process. So mathematics plays a very important role. It's very, very essential to use mathematics to explain scientific concepts. For example, Newton. Everybody knew that apple falls down. What was special about Newton? He gave mathematical explanation of the phenomena of gravity. Maxwell, he explained the electromagnetic theory in mathematical terms. So many scientists used to go to Maxwell to understand their theories in a mathematical way, to represent it in front of the world, so that world will accept their theories. Now, sometimes students feel maths as challenging. But remember, maths help us in many ways. It's not an hurdle. Instead, it is a language that helps us to clearly think about some processes. An equation is not just a calculation tool, it's a compact statement. Okay? X belongs to natural numbers. So you can show it in scientific terms, in mathematical terms. It has some meaning. It tells us about the truth of the universe. So people say that God's language can be understood by mathematics. Complex systems can be broken down into simpler parts which we can understand by mathematics. So Describing motion using quantities such as distance, time, velocity allows us to answer questions about where the object will be. So Newton's laws, they are so precise, they are so accurate. You can just put the date and you'll know where the earth will with respect to the sun. Any date for your knowledge. There are softwares which use the calculations to find out the distance between earth and moon, between earth and sun, between earth and Jupiter. You just put the values, put the date, time, and you get everything. It's very precise, very accurate. These models help us for space exploration. We go to moon, we go to Mars using these models. Same way, chemical reactions, pattern of population growth, all these things could be understood in simple way by using mathematics. So mathematics is very powerful to understand science. If you focus first on understanding the situation and quantities involved, equation will begin to feel less like an obstacle and more like a helpful guide. Okay, so let's take example that in your city there is always traffic jam. So what are the variables? Number of vehicles has increased, the roads are small. Like that you can put many variables and make an equation to understand the situation. This is actually done by government. Then where should we have the traffic signal? What should be the condition of the road? So you build a model and see if it works. Do some changes in the traffic as it is flowing in day-to-day life and check what is the use. For this, mathematical data, scientific data is very essential. A well-known incident happened where a passenger aircraft ran out of fuel mid-flight because of mix-up of units. So it needed 22,300 kilo in total, but the ground crew miscalculated the fuel because the density was in pounds per liter rather than kilogram per liter. Now everybody uses kilogram. Okay, it's very important. Now this aircraft was not damaged, it successfully landed. Okay, there were no casualties, nobody died there. Now we have standard units which are used everywhere in the world so that we are on the same page. Okay, now why is kilogram used everywhere? So we buy rice, vegetables, and we expect kilogram to mean the same thing. So if you go to vegetable vendor or in a grocery shop, 1 kg is same for everyone. That is what we understand. That's called as a standard. Now observations are repeated, measurements are refined, and ideas are tested through experiment. We can organize our understanding of the world. So we are in this world. We look around and we try to understand what the world is made up of. We do observations, we do calculations, and we refine the calculations, measurements, okay, and try to make sense what is actually happening with us, what is happening around us. Now in secondary stage you will come across terms such as laws, theories, and principles. So what is a law? Law usually describes a regular pattern observed in nature. Sun rises in the east, you observe it every day. Okay, you make some laws. Ohm's law is there, which you are going to study afterwards. Okay, Joule's law is there. They are laws, we observe the things. Regular patterns are there, we observe it and write it in form of a mathematical relationship. Newton's law, okay, Kepler's law, many laws are there. So Newton's law help us to explain the jerk that we feel when a bus stops suddenly. A theory goes step forward and explain why these things are happening. Okay, for example, atomic theory explains how molecules are formed. Then principles are broad ideas that make sense in a given situation. For example, principle of conservation of energy. So do remember that in science, a theory does not mean a guess or untested ideas. I cannot say whatever I want. It should be backed by evidence. I have to give evidence for a theory. And my theory can be changed anytime. It can be discarded. A new theory can take its place. That is the beauty of science. One's most remarkable strength of the science is the ability to make predictions. So whatever laws, theories we have, we can make predictions. So last year it rained in June, so we can make prediction next year when it is going to rain. Last year it was very cold, so lowest temperature suppose was 5 degrees Celsius. So we can predict next year maybe it happen that the temperatures will reduce to 5 degree in winter. So these are called predictions. With the help of mathematical models and scientific experiments and facts, theories, we can make prediction. That is a great thing. So when laws, theories and models are well established, we can anticipate what is going to happen. Using these ideas about motion, we can predict how far a kicked football will travel. Use knowledge in chemical reactions, we can estimate how much carbon dioxide will be produced. So if you burn coal, how much carbon dioxide will be produced? You burn wood, how much carbon dioxide will be produced? You have theories related to it, and they are very powerful. Now, if our observations are not matched, if the experimental result don't conclude as we expected, we can change the theory. That's a powerful thing. So how can we check the predictions? Varsha told a friend Meghna it will rain in the afternoon because the clouds look dark. So some questions could be asked. So some scientific questions could be. Now you cannot ask yes and no questions. You have to go in detail. What was the condition of the sky when it rained last time? What was the humidity? Was it about 80% last time? So you do calculations, you do observations, you record things. Okay, now let's go ahead. Such failures are not weakness of science. So sometimes the theory may fail. The observations may not be in accordance with the theory that we have proposed. So that is not a bad thing. That's a good thing. You are improving. You are trying to understand what is actually happening with you in your surroundings. So no scientific theory is ever final and none is beyond questions. You can question any theory and you can find out evidence against it and you can define conditions for that theory. So there was a viral claim on social media that it is harmful to eat food during an eclipse. So you check it. So what is the physical evidence? You can check the food before the eclipse, after the eclipse, during the eclipse. And if there is no evidence, we can discard this thing. So does temperature change significantly? Does the food go bad if it is left in shadow? We'll conclude with no physical evidence. So it's something to be discarded. It is just superstition. So as you continue your journey, 9th and 10th will develop habits of thinking beyond the classroom. So you have to think out of the box. Not only what is given in the textbook, you have to explore on your own. That is what is said. A helpful strategy is to first understand the situation, identify the quantities, make rough estimates, and answer whether an answer is exact, whether it makes some sense. Exact values are not necessary. So early stage of reasoning, no need of exact measurements. But we can guess some things. Learning to estimate helps us to understand intuition, detect errors, and develop confidence in your thinking. Now, science values careful reasoning, perhaps much more than accurate calculations. Okay? Here they are given the example. How much rice would feed a family for a month? So you calculate how much rice you require every day, and you calculate for a month. You can do that. Very easy. How many members are there? You multiply, use mathematics for it. Another example is given here. Estimate how many liters of air you breathe. Okay. So you can just read this, you'll understand. Do the calculations. After 10th grade, if you decide to learn science, there are many branches of science. Physics is there, chemistry is there, biology is there. And they are all interrelated. They are called as interdisciplinary science. Okay, it's not that chemistry is separate from physics. We have physics in chemistry and chemistry in physics. It's all related to each other. And mathematics is everywhere, remember. So science also connect naturally with mathematics, technology, art, social science to make sense of the world fully. We need to connect all this in multiple ways, and that is what the future is. Now pause and ponder. You have to pause, look at the surrounding, think about it, why this is happening, how this is happening, and then many connections will come up. Now, how does a mask really work? So here they are telling us our day-to-day life. We are going to relate science to day-to-day life. A surgical mask. So many things are involved in it. Understanding how the mask works. What is the physics behind it? Electrostatic attraction. What is the chemistry behind it? What kind of material, polymer is used here? Biology. Understanding the behavior of viruses, pathogens. So all these things together. So finally, mentioned in every textbook, science is not just a collection of facts, equations or experiments. It's about our everyday life. Remember, what you can do, you should be curious, you have to be creative, you have to collaborate with your friends, ask questions, okay, develop a scientific attitude. That is what is told to us. Happy exploring. Thank you very much.